One of the most common use cases of AI models is to do retrieval augmented generation on financial data. A lot of banks, a lot of financial institutions, investment firms, they are looking to have their own model which would work on their own private confidential data of the past several decades. Now, in order to make that data LLM compliant, first it needs to be converted into a numerical representation, and then because we will be doing a retrieval augmented generation on top of it, we need to make sure that there is some similarity search enabled. All of this becomes possible with embedding models or sentence transformer models. If you don't know what sentence transformer model is, I just did a video, as you can see here on my channel, about sentence transformers, as what exactly they mean, how to install, and what is the difference between the library and the model, and a lot of other things. And I would highly suggest that if you're looking to implement your own embedding model, have a look at this video. Coming back to this model, which is an embedding model on the financial data on a private data set of this person who has created it, it is quite performant. In this video, we will be installing this finance embedding model, and then we will also do a similarity search. If you don't know what RAG is, RAG basically is a method or a technique which enables you to give LLM a context of your own data. So what happens is that first you convert your data to numerical representations. Those numerical representations or embeddings or vectors are stored in the vector database. And whenever someone queries an LLM about their own data, your own financial data, first that query is converted to a numerical representation. Then a similarity search is done in the vector store to return the results which are similar to the query, and then those results are augmented or joined with the prompt, and then they are given to LLM. And then LLM has not only your query but also the context of your own data, and then it generates more informed response. So that is the whole story behind RAG. And this finance embedding large model enables you to do embeddings or similarity search on the financial data. So let's see how it works. How can we get it installed locally? And then we will go from there. The VM and the GPU which I will be using for this video is very generously sponsored by our good friends at Mast Compute. So if you're looking to rent a GPU on affordable prices with no lock-in contract, very flexible offering, then I will drop the link to their website in video's description. I will also put in a coupon code. If you would use that, you will get 50% discount on an already discounted offering from Mast Compute. So huge shout out to them for this generosity. Let me take you to my local system where I am running Ubuntu 22.04, and the GPU which I am using is this NVIDIA RTX A6000 with 48 GB of VRAM. It's not a big model, so you don't need that much VRAM. So if you have a smaller GPU from Mast Compute or your own, you can use this one. Let me clear the screen. Another thing which I always recommend is to have Conda installed, which will keep everything separate from your local installation. You can see that I already have Conda 24.1.2 installed. Let me clear the screen and let me create the Conda environment. It will not take too long. Just press Y here, and that is going to create your Conda environment. Now it is created. Let's step into that Conda environment by activating it, and you will see that it appears in the parenthesis on the left hand side. Let's clear the screen. Now let's install first sentence transformers, and then which is used for these embedding models, and then we are going to install this model. So I'm just using pip command to install that. Let's wait for it to finish. It just takes a minute. Sentence transformers is installed. Let me clear the screen, and now let me launch my Python interpreter, and we will install this model. First, let's specify the model, which is finance embedding large. Okay, so it says sentence transformers is not defined, so we need to import that library, which I forgot to do. Let me do that quickly. This is a command we first need to run because we need to import the sentence transformers. That shouldn't take too long now. That is done, and now let me run this command again. And this time, sorry. You see now it is downloading the model. The size is just 1.34 gig, and these embeddings or sentence transformer models are relatively small. So let's wait for it to finish. That is done. And now let's specify our input. So these are the three sentences which I will be giving to the model. And if you look at them, all three of them are finance related. That how many companies are listed on the New York Stock Exchange, what are the trading hours of this exchange, why do Maple Leaf coins, and all that stuff. And we want to see which of these sentences are similar, because that is what our semantic search, similarity search, or RAG requires. Now, before I move further, let me show you an example as what exactly we are going to do. So the purpose of a sentence transformer model, which in this case is finance embedding large model, is to do similarity search. And in order to do the similarity search, first it needs to convert these text values into numerical values, which is called as embedding. Let's take this example. In this example, we have three sentences and we have converted them to a numerical representation or vector, and the dimensions of that vector is 1024 in our case. So what it means is that in this array or in this vector, we have 1024 values. So for all these three sentences, we have first converted them to these embeddings or vectors. And then when it comes to similarity search, we compare these, and wherever there is an more similarity or identical one, the value is 1, and if there is no similarity, value is 0 or in between. So for example, you see I love dogs and I love dogs, they are identical, so similarity is 100% 1. And if you see I love dogs and dogs are the best, because both have the word dog in them, it's 0.8. But if you compare I love dog with cats are amazing, this is 0.2 because they are not similar. So this is what a sentence transformer model does. If you go back to the terminal, this is what we are going to see, that in these three sentences, what exactly is the similarity. Now, in order to do that, first let's convert these sentences into embeddings. For that, we use this function encode of our sentence transformers. So we have converted it into embeddings. Let's print this embeddings shape. It says it is 3, 10, 24. 3 means that there are 3 sentences, and 10, 24 means that there are 10, 24 numerical representations of vectors on, and this is basically the whole high dimensional space where it represents a point. Okay, so we now know what is the shape of this. Now let's do the similarity search to see how much these sentences are similar to each other. And I'm using similarity function. That is done. And now let's get the similarity table, which I already showed you in example. So this is our similarity shape, that 3 by 3. And if you print these similarities, there you go. So you see the first sentence is identical, so 1. So if I just quickly take you back to the example, you see again this is 1, the first one, first column, first row. I love dog, I love dogs. The second column, second row. And then here in the second row, in the third column, again it is identical, and similarly that. Let's go back to our terminal. In this one, you see this is identical, this is identical, this is identical. And similarly, the things which are not really similar, they are being shown here. This is totally not similar, this Maple Leaf one, right? And then this is bit similar because they have a stock exchange word. This is not, this is very, very slightly similar, but not much. They are not similar, they are not similar. This is halfway similar. So by looking at these vectors, because models and all these computer programs, they understand numbers. So by just comparing these numbers, they can tell which values are similar or not. Now, for example, a user comes in and a user asks a question about New York Stock Exchange. What would happen is your RAG pipeline will convert that question into numerical representation. It will make that search of similarity in this whole vector store, and then it will return only the values like maybe this and this back to the RAG pipeline, which is just going to use another model called as re-ranker, which will just pick up the top 3 values, let's say, or top 1 value, and then that will be augmented or joined with that user's query and given to LLM. LLM will have the best similar vector from your database plus your prompt, and it will have more context around your query from your own data. So this is the advantage of these embedding or sentence transformer models, and that is how you can use them in your RAG pipeline. So I hope this was useful. Let me know what do you think. If you have any questions, let me know. If you like the content, please consider subscribing to the channel, and if you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.